Good day, everyone. We are here to present our research on the effects of Saudis PTSD in disinfecting groundwater using different water bottles in Bulawan, Palawig, Zambales. Let's start with the background section of our poster. Access to safe drinking water remains a significant challenge in Zambales, particularly due to microbial contamination from sources like E. coli. Solar water disinfection or SODIS is a widely recognized, low-cost method that uses sunlight to inactivate harmful microorganisms. To enhance its effectiveness, we integrated SODIS with the Parabolic Trough Solar Collector or PTSC. This increases sunlight exposure, raising water temperatures for improved disinfection. In the research questions section, we aim to answer the following. Number 1. How does the different duration of sunlight exposure using SODIS PTSC in PET, glass, and polycarbonate bottles affect microbial contamination in groundwater from Bulawan, Zambales? Number 2. How does varying temperature affect the performance of SODIS PTSC in PET, glass, and polycarbonate bottles? Number 3. What is the turbidity level of groundwater in Bulawan, Zambales after the use of SODIS PTSC in PET, glass, and polycarbonate bottles? Our objective is to determine whether SODIS PTSC is effective in reducing microbial contamination and ensuring safer drinking water. Next, we have the methodology section, which outlines our research process. For our research design, we applied a descriptive quantitative approach to measure the effects of SODIS PTSC. For a research sample, groundwater samples were collected from Barangay Bulawan, Palawig, Zambales. And for our research instruments, as shown in the poster, we used PET, glass, and polycarbonate bottles, a thermometer for temperature monitoring, and laboratory pipette, Philippine Institute of Pure and Applied Chemistry for coliform testing to measure E. coli levels, and Hydrolab Company for turbidity analysis to evaluate water clarity. In the SOLIS PTSC model diagram, you can see how sunlight is concentrated using the parabolic trough solar collector to enhance disinfection. For our data collection procedure, water samples were placed in each bottle type and exposed to sunlight for 4, 6, and 8 hours. Temperature was monitored using a thermometer, and E. coli levels were measured using the multiple tube fermentation technique or MTFT and the enzyme substrate test. Turbidity was also assessed to observe water clarity. The systematic approach allowed us to ensure accurate and reliable results. Now let's move on to the results and discussion section. Table 1 presents the E. coli test results. After 4, 6, and 8 hours, most samples showed E. coli levels below 1 most probable number per 100 ml, meeting the Department of Health 2007 Philippine National Standards for Drinking Water. Figure 5 displays the temperature data. All materials reach an average temperature of 43 degrees Celsius after 4 hours, which was sufficient to contribute to microbial reduction. Figure 6 compares E. coli reduction across the three bottle types. PET and glass bottles showed that significant reductions in E. coli counts, achieving levels below 1 most probable number per 100 ml after 4 hours. Polycarbonate bottles, however, showed a slower reduction with E. coli levels remaining at 2.0 most probable number per 100 ml even after 6 hours of sunlight exposure. This indicates that polycarbonate was less effective in achieving complete disinfection within the same time frame. Figure 7 focuses on turbidity levels. PET bottles maintain clearer water compared to glass and polycarbonate, indicating better overall water quality. These results confirm that Solid PTSC effectively disinfects contaminated water, with PET and glass bottles performing best in terms of E. coli reduction and water clarity. Based on our findings, we conclude the following. SODIS PTSC is a reliable, low-cost water disinfection method, particularly for areas with limited access to clean water. PET and glass bottles demonstrated superior performance in both E. coli reduction and maintaining clear water, and polycarbonate bottles were less effective as E. coli levels remained at 2.0 most probable number per 100 ml after 6 hours, highlighting the material's limitations in disinfection. This result suggests that PET and glass bottles are the most practical choices for SODIS PTSC applications in water-scarce communities. In the limitation section, we recognize the following. Our study was limited to microbial contamination and did not evaluate the presence of chemical pollutants. And environmental factors like inconsistent sunlight exposure may have influenced temperature readings. For future research, we recommend conducting longer term studies across different weather conditions, exploring additional bottled materials with improved UV transmittance, and expanding the research to assess chemical contaminants in water sources. We would like to express our deepest gratitude to NU Nazareth School, our research advisor, and the residents of Barangay Bulawan for their support. We also extend our heartfelt thanks to the laboratories that made this study possible. PIPAC for conducting the coliform testing to accurately measure E. coli levels, and Hydrolab Company for performing the turbidity analysis to ensure the clarity and quality of our water samples. Your expertise and support were invaluable in ensuring the success of this research. So this PTSC has the potential to make a significant impact in improving water safety in rural communities. Thank you for your time and attention for listening.